Hello again, you sick, twisted weather freaks, and welcome to another fun filled, action packed, and intellectually stimulating edition of This Week in Weather. I'm your host and meteorologist DT from Weather Risk, your captain of chaos, your colonel of confusion, the commander of catastrophe. Let's talk about the son of Ian. And we're going to call Ian, which is, of course, still a hurricane, but rapidly weakening now, the son of Ian because it's sort of like a sequel, like in a movie or what have you. And also because by the time we get to Monday night and Tuesday, people in the middle Atlantic are going to be saying, son of an Ian, when is this rain going to end? When is the wind going to stop? When's the sun coming out? So a lot to talk about here. Now, in this edition of This Week Weather, go over some key points here. First, why did Ian turn so sharply to the northeast when every other model up until Monday morning, really, or Sunday night, had it going, really Monday morning, actually, Monday afternoon, had it going almost due north or going into the Big Bend area of Florida? Why was only the GFS, only the European and the British model and the German model had it turning to the northeast? All the other models were completely off. The hurricane models, the GFS, the Canadian, they sucked. So we'll go over that. Will the GFS ever be any good beyond 72 hours? And I doubt it. We'll get into that in a second. Why were the winds much stronger on the western side of Ian? Wasn't it supposed to be like the eastern side, the northeast side, the really strong side? Well, in Ian, that was not the case. We'll go over that. Will Ian become a hurricane, or will it increase on Friday once it goes back over water, east of Daytona Beach and turns north? What then? Will Ian's remain still be around? How much rain? Who's going to get it? Where? What areas? How much wind? Is there a tornado threat? Yeah, for Georgia and South Carolina and southern North Carolina, but not any further north. Flooding? Yeah, there's going to be some of that in the coastal areas and inland in the valleys, no doubt about it. Mountain and valleys are going to get a lot of rain here, so we'll go into that. And travel and power loss. Okay, so this was Ian when it made landfall this morning. You can see the satellite picture here. This is actually midday. This is 2 o'clock in the afternoon, I should say. So it's not this morning. You can see it really coming ashore now. Now notice at this point here, half of the eye is actually on the coast there, in the Fort Myers metro area. And you can see, hitting the islands, the barrier islands there in southwest Florida. And you can see it's just a monstrally powerful hurricane, very, very intense. And of course, this was the data here. This is why people got really excited. And you can see that the time when this happened, this was earlier this morning, on Wednesday morning. You can see that the pressure here in the green did actually get down very close to 933 millibars, and the maximum flight level winds, again, I have in black there, you can see it, are 150 knots, which is 175 miles an hour. And the surface wind, they did have a surface wind reading of 135 miles per hour, so which is 135 knots, 155 miles per hour, so very impressive. Now this was from Stu Ostro. I want to show this again. This is a comparison between how tiny Hurricane Charlie was in 2004 versus the monster storm that Ian had become. So it was significantly different and much more powerful. I think this is an excellent image from a really good scientist, Stu Ostro, over from the Weather Channel fame. Now, this showed the problem here this afternoon. Again, this is at 2 o'clock in the afternoon. You can see they had a drop sound here. One of these, these little these pieces of instrumentation which they drop from the hurricane plane that go all the way down to the surface and gives you readings and information about what's going on. And you can see here as you look at it at here on the lower right here, 952 millibars, the altimeter there, which is 1,400 feet above the ground. They had a 137 knots or 157 miles per hour just above the ground. Really incredible winds here. And you can look as you go further up, 2,000 feet, 5,000 feet, 6,000 feet, 159 knots at 900 millibars, which is 4,000 feet above the ground, which that's 180 miles an hour. So amazing amount of wind here. Very, very impressive. Now, the other thing is when you have a hurricane like this, notice what it's doing here. You're getting the winds. Let me call my marker here so you can see it. So the winds here are doing this. So Tampa, they're blowing the water out. You see this huge amount of wind from the easterly direction blowing the water out of the bay. See what it was doing here? Of course, here it's blowing it in, obviously. But that's what it was doing. And the reason I mention that, because this is from Tampa. This was the bay. Water was completely blown out of the bay. Unbelievable. Now that happened to some degree with, I think, Charlie or one of the other hurricanes, but this was really quite remarkable. Now, let me show you. This is for the western side here. 4 o'clock this afternoon at Cape Coral, okay, they had a wind of 112 miles per hour sustained and a gust of 135. That's on the western side of the hurricane. The eye wall is the western side. That was just coming ashore in the afternoon hours. I mean, if this is where it is at 2 o'clock, you can imagine that here the western side is going to be like at 4 o'clock by the time it gets here. That's exactly what happened. So the report matches. And there are a lot of reports. You can see this guy on Twitter. And again, you don't need a Twitter account to see this stuff. You just go on, it gets open. You can see the video here. Absolutely insane wind gust here in the afternoon. Now it was 6 o'clock, in the this evening. He was getting pounded. Just pounded. Now, that's not when the video was taken. I think that's when it uploaded. But this was this afternoon. You can see unbelievable winds. 150 mile an hour wind gust here. It has to be. Unbelievable. Here's another one. This is from Mike Seidel. Now, Mike is great. He's been in so many hurricanes. He should know. Now, here, we're on the eye wall, Category 4 hurricane on the western side, the backside, which is the worst I've ever seen in more than 30 years of doing hurricanes. Again, you have to watch these videos. They're unbelievable. Unbelievable. Now, again, why was the western side? Let me show you. Here's the satellite picture. This is as of 2 o'clock, almost 3 o'clock this afternoon. You can see, again, the eastern side of the eye wall, right here, the eastern side, is now on land. So the winds are still very strong here over the open water. So that's one reason. The winds here are very strong on the western side. On the eastern side, we're already getting friction. You see how the eastern side is falling apart? But here, look at all the cloud mass to the north coming around this way. So the winds pick up in the heavy rain bands, and they really whip around the western side of it here, completely unopposed by any land friction. So that's one reason. Okay? And, and it's also not moving very fast. It's moving pretty slow. And that's one thing. We can take this. We're going to need it. And then we'll take this here. Now it's inland. Okay, now this is this evening. You can see that the eye is now inland, okay, by east of Port Charlotte, okay, northeast of Fort Myers. But again, the western side of it is still really ripping. See that? Still getting those tremendous winds. So this is the winds are all picking up on the western side, still out over the open water. The eye is inland, but the western side is not. The other reason here, and this is the big reason, this is a comparison. You can see here the high pressure area over the Great Lakes, 1035 millibars, plus you have the hurricane there in southwest Florida. And the thing is, look at the pressure gradient. And by pressure gradient, I'm talking about the isobar lines. Okay? I'm talking about these things. You see the lines here? See these black lines? These are the isobars. See this? The isobars. You see the isobars here? Isobars. So the high is pressing down and the hurricane is coming north. So that's increasing the pressure gradient on the northwest side. That's why the wind stayed up so strong on the northwest side. We had pressure gradient here. You know when this was just like? This was just like Irene in Virginia in 2011. All the models were forecasting 20 to 40 mile an hour winds in central Virginia. And the TV meteorologists are talking about that. But I said that we're going to have winds 40 to 70 miles an hour. And the reason is because I saw the pressure gradient of high pressure coming down from Michigan into Ohio, pushing up against the western side of the hurricane. And of course, if you look at the data, Richmond had a wind gust of 73 miles per hour. Or like there were 70 miles an hour in Richmond several times. Okay, much stronger than anybody thought. And that's why the power was out for many places for 5, 6, 7 days. The winds were much stronger than people thought, and the models missed it. So that happens from time to time. When you have pressure gradient, the western side of the hurricane can be much stronger than the eastern side. So yes, to answer your question, that's exactly what happened. Here it is on the evening satellite picture. You can see this is almost 8 o'clock this evening. There's still an eye. Technically, there is still an eye here. It's well inland and still an eye. Very impressive system. Okay. Let's talk about what happened last week. Back on Sunday, Sunday we did the last video. The issue was this monster trough here. So you can see this is the trough on the European right here, very sharp, and here was the GFS. But the GFS was swinging the hurricane way out into the central Gulf of Mexico. It was going over almost the Yucatan and then going out this far. The European had it hitting the western tip of Cuba and then approaching southwest Florida. So the trough here was much closer, and that was able to turn it. So the difference here is that the GFS was just missing it. it it just missed it and didn't understand the connection between the distance between the base of the trough and the hurricane, and the European did. It's the same distance on both models. This is the same distance, but the GFS, being a poorer model, is just not going to do it. The thing that makes the European so good here is its initialization. It's how they initialize the data. They use a much higher parameterization scheme. That's why the European comes out later in the day in the cycle than the GFS. It takes longer to put the data in and to quality control the data. So because the GFS doesn't do that, it misses things beyond 72 hours. Again, remember what the model here was. Look at all the hurricane models. All these hurricane models, all of them, they run off the GFS grid. So if the GFS is showing it's missing the trough, there's the GFS. Taking it, it was a 927, a little too strong, but a very good forecast considering it's 102 hours out. Okay, but taking it due north, and of course moving it due north into the dry air, all this dry air gets sucked into it, and the hurricane would collapse as it approached the Florida Panhandle. That's what we look at. Look how the model is showing. Okay, 931, then 966 as it approached the coast. It would weaken dramatically. Why? Because of all the cool, dry air with temperatures in the 40s and 50s in Mississippi, Alabama, and Georgia. But if the hurricane turned to the right, like the European was showing, this is the European from September 24, going over Cuba, making landfall south of Tampa near Fort Myers. Another amazing job by the European model, absolutely amazing. It stays in the mild air, you see? Look at the air mass here. If the hurricane does this, if Ian is doing this, going to southwest Florida, it stays in the mild, humid, warm air. So all this cold, dry air does not get entrained to it. So the system stays warm and it continues to intensify. So not only did the GFS miss this, but by doing this, it missed the intensification at the end. So once again, all the hurricane models, they run off the GFS grid. If the GFS is doing this and taking it north and weakening, that's all going to do that. So that's why what they really need to do is they need to run some of the hurricane models off, not using the GFS grid, because it's really flawed that way. And sure enough, there's the European. The German model did it. The British model showed the turn. The European model showed the turn. They did not. And show you again, the European, now it had much higher winds. It had winds 125 miles an hour, which verified in Tampa. Now, of course, the winds were a little further south. It was more Fort Myers. It didn't get that in Tampa. But it had for 156 hours, 6.5 days out, that's a damn good forecast. This is a damn good forecast. And in comparison, this chart, now what is this chart? What they do is they run statistics. They run the chart to find out, like football or baseball, who's got the best team, which is the best model. And over here on the right hand side, this is the mean absolute error in kilometers. So the higher the number, the worse the model. Okay? So for example, these are the different color coding here. So at 24 hours out, look at here's the red burgundy color is the GFS. You see that? Let me call it up here, you can see it. There you go. The burgundy color, that's the GFS. This is the European, the blue. See that? Okay? And the green is the British model. So 24 hours out, they're all the same. At 48 hours out, the British model, the American and the European are about the same. But at 72 hours out, look how much higher the GFS is versus the European. Okay? This is worse. The top of the score, this is worse, this is better. Worse, better. Okay? At 96 hours out, look at the difference in the error here between the European, better than any other model here. European, better than any other model, 72 at 96 and 120 hours. Look how more accurate the European is than any other model here. See that? And then here at 96, look at the difference. Unbelievable between the American and the European, the GFS and the European. So again, and again, any model should be able to get the next 24 hours right with a track of a low pressure area or a hurricane, or at 48 hours. That's not that hard. But once you get to 72 hours out, the GFS just falls into a pile of crap. So there you go. Okay, let's move on. Here's the 18Z hurricane models. I know the 0Z is already out. It does the same sort of thing. Takes off the coast of Daytona, then towards into South Carolina, and then moves in the west of North Carolina where it doesn't do much and it stalls, and it just rains and rains and rains and rains. And you can see why. Here's the 8 p.m. advisory. It does the same sort of thing. You can see it's not much of a change. Now, it's not going to get a chance to re-intensify into a hurricane. It won't do that. It will pick up some speed and some intensity, but the other reason is because what you'll see when it is doing up like this, again, the circulation is very large. So when it's coming up the coast, the circulation is pulling in dry, cool air from Georgia and North Carolina and Alabama, getting it entrained to the system. The western side is going to pull in a lot of cool, dry air because of the cold, high pressure up in Michigan and the Great Lakes. So that's going to weaken the western side of it. So it's not going to re-intensify to a hurricane. But let's take a look what is going to happen. Okay, so this is now Thursday afternoon. There's Ian moving off the coast of Daytona Beach, East Central Florida. There's the trough leaving the East Coast. And look at this enormous ridge right here. Okay, you see this ridge here? So you have an upper low in Idaho and the ridge. Now what's going to happen is that once this trough here leaves, this ridge is going to build in. It's going to block Ian. And it's going to keep Ian running right stuck over the mid-Atlantic stage. You'll see what I'm talking about in just a second. So here we go. This is now Friday night, early Saturday morning. There's Ian in Georgia, South Carolina. We have 3 upper lows in this map. One here in the eastern Pacific, one in Idaho, and there's Ian, right? And the ridge is getting very strong in western Canada, okay? And this is what it looks like at the surface. Here's the GFS. You can see there's the low, okay, east of Jacksonville, trying to regain a little bit of strength, but notice again here, the western side. The western side is completely dead. See that? All of it's on the eastern side. Okay, nothing on the western side at all. So this means Tallahassee. You're not going to see anything. This is right, Tallahassee. Don't worry about it. You're fine. I'm not even sure how much Jacksonville is going to see. And then here we go. Now this is Saturday morning, 2 a.m. And there it is, making landfall in Charleston, moving into South Carolina. The heavy rain is already almost up to DC at this point. So the rain is really going to roar in here on Friday. Okay, the rain is, this line here is really going to sweep in here by Friday afternoon, evening, so that by the time we get to, it's about to start raining in DC by 1, 2 a.m. on Saturday morning. And the rain is already pushed into Roanoke. See that? Tremendous rain and wind here in the Carolinas and pushing into southern Virginia. Look at the pressure gradient. Look at the lines. Okay, so now here is 90 hours. This is now Sunday morning. Okay, 2 a.m. Now the ridge is expanded. So let's look at the ridge here. You see where it started out? The ridge is expanding eastward. You see that? It's expanding eastward. It's blocking Ian from getting out to sea. There's Sunday, and this is Monday morning. This ridge is now moved into the Great Lakes and Quebec, Canada, and Ian, or the remains of it, which is now a coastal low, has become trapped. It can't go anyplace. The ridge is blocking it to the north. And let me show you what happens. Okay, so this is Saturday. Look at these winds. Look at the isobars here on Saturday, Friday night, Saturday, in Virginia, North Carolina, Southwest Virginia, southern portions of West Virginia, even to eastern Kentucky. Look at these winds and rain. It is going to be a awful Friday night, Saturday, and weekend. And let me show you. This just goes on and on and on. This is now Saturday morning in the upper left. Sunday morning, 2 a.m. Now there's a bit of a break right here. You see this? You see right in here, there's a bit of a break here. If you're in central and east North Carolina, you're okay. Rain comes to an end now Saturday night, Sunday morning in central and eastern Virginia, the Delmarva. See, the main band is here, but look at this upper low here. The upper low is still here. See this? Okay. So then, let me send this back. Okay. Now look at let me blow this one up here a little bit so you can see it. Look at this thing here. The low is here now. This is now Sunday night. Sunday night, the low is moving east again. The rain redevelops here. Heavy, heavy rain. Virginia, Maryland, Delaware. Moderate rain, southern Pennsylvania, West Virginia, western North Carolina. And then now this is now Monday. Bring this one front. Look at the rain on Monday. Driving rain. Look at these winds. Oh my, it is going to be so, and the temperatures are going to be in the 40s and 50s, except for eastern Virginia and southeast North Carolina, they may get to the 60s or 70s at some point. But this is, look at the northeast winds bringing the cold air down. The big high to the north. Man, if this is winter, well, never mind. So anyway, so let me bring this one back, and you can see now. Now this here is Monday night. It's still raining. It's still raining. Can you believe this? Now the rain's pushed up into Pennsylvania, southern New Jersey, heavy rain north of Richmond, all throughout the northern Shenandoah Valley, D.C., Baltimore, Piedmont, all of West Maryland, West Virginia, just coming down buckets. Now there's a dry slot right in Hampton Roads, you can see that, and eastern North Carolina. They've dry slotted, their precipitation is over that point. And then this is now here Tuesday evening. The rain's still raining in D.C., showers at least, moderate, light to moderate rain, eastern Pennsylvania, New Jersey, New York City, Delaware, but it's coming to an end at this point. Look at these winds. This is the new NAM, just came out. Look at the winds here for Friday afternoon. 50, 60-mile wind gusts in South Carolina, Greensboro, Spartanburg, Raleigh, Charlotte, Greensboro, Columbia. But look even into southern Virginia, 30 and 40-mile wind gusts in the southern half of Virginia. Richmond, Lynchburg, Hampton Roads, Williamsburg, Farmville, Roanoke, Danville, Martinsville, Hillsville, all getting pounded. Okay, and this is with rain. Now this is now a Saturday morning. This is actually Friday night, midnight, just about. And look at the winds just howling across Southwest Virginia. I mean, it's going to storm in Southwest Virginia. I hope you folks in Southwest Virginia are ready for this. If these winds are right, you're going to lose power. You're going to lose power. Okay? Same thing here in the Western Carolinas. You're going to lose power. You're going to lose it. Be prepared for it. And the rain and the wind is going to make it really miserable out there. Okay? Even in Richmond, Richmond's getting gusts of 40. So is Ashland, Charlottesville. And then when you get to Roanoke and Lynchburg and all that area back there, Lexington, Staunton, it's going to Bluefield, Beckley. I mean, look at that. Nasty day. And then even beyond that, this is Saturday afternoon, 1 o'clock. And here, look at, again, 34-mile winds. This is Sunday morning at 8 a.m. 20 to 30 mile winds in maximum gusts. This is a Sunday evening, 20, 30, 35 mile wind gusts. The green is 35. With rain still coming down. Again, this is Sunday night. Look at Sunday night. We talked about that. This is Sunday night. It's gonna suck. And then this is now here Monday morning, 11 a.m. Look at the wind still cranking. Are you kidding me? Are you kidding me? And about the rainfall. Here's the rain shield. Look at this. Total rainfall by Monday and Tuesday morning. 3 to 8, 10 inches of rain. The white spots, 10 inches of rain east of Richmond and King and William. 7 inches up towards Culpeper, Warrington. A lot of rain coming. Yes, here's the Canadian. And the Canadian has the heaviest rain just south of the North Carolina-Virginia border. That might be right, Now, both areas, look at both maps. Look how sharp the rain cutoff line is. Both these maps, you see that? Very sharp. That's because when you get to this high pressure area here, the rain's only going to go so far north. So there you go. And then finally, beyond that, and I didn't even post the temperatures. Maybe if I do an update, I'll show you the temperatures. With these winds, it's going to make it feel terrible. It's going to make it feel like November outside, So if you got plans, change them. And the other thing is, in this sort of stuff here, any area that floods on the coast is going to have coastal flooding problems with these prolonged east winds. Any area on the coast, these prolonged east winds are going to pile up the water. They're just going to pile up the water here Friday, Saturday, Sunday into Monday. So any place in North Carolina, Hampton Roads, the Bay, the lower Virginia eastern shore of the Delmarva, you're going to flood. Now, I don't know how bad it's going to be. That has to be worked out yet, but you prepare for it. Okay? Hampton Roads, Hampton, Poquoson, Portsmouth. Now, inland, in the valleys, okay, if you're getting rain like this, 3, 6, 7 inches of rain in the valleys, you're going to flood in the areas which have poor drainage. There's no doubt about it. And the other thing is a lot of leaves are already turning in the valley in West Virginia, the mountains in western central North Carolina, Maryland, Southwest Virginia. This is going to pull down a lot of leaves. It's going to pull down a lot of leaves. So don't, keep that in mind too. They cause problems with road traction, and they enhance, flooding with the drainage areas. So, be prepared for that as well. All right, finally, beyond all this, just to let you know that in the middle of October, we keep a mean trough in the eastern U.S., so the temperatures look either normal or slightly below normal. Whew, that's the report. I need a chocolate chip muffin. That's what I need. I need to get a muffin. Okay, and a hot tea. This is meteorologist DT from Weather Risk. I'll see you over on the Twitter page, over on the website, and over on the Facebook page.